Motion is the change of an object's position with time. In physics, position is a vector quantity. This means that it not only has a magnitude or value, which is given by the length of the arrow, but it also has a direction in space. We express this direction in terms of coordinates. When talking about motion, it is important to distinguish between distance, which is the amount of ground covered by the object, and displacement, which is the change in position. As can be seen in the figure, the distance depends on the path taken, but the displacement doesn't. Distance is a scalar quantity, while displacement is a vector quantity, because it is the difference between two position vectors. The change in position with respect to time is what we call velocity. Like position, velocity is a vector, pointing in the direction of motion. The magnitude of the velocity vector is also known as speed. It is important to keep in mind that speed and velocity are not the same thing. These two cars, for example, have the same speed, but different velocities. We can compute the average velocity of an object for a given displacement as the position increment divided by the time increment. In one dimension, we can express it like this. However, the velocity of the object at a given instant may be very different from this average velocity. See this graph, for example. The curve shows the velocity of the car versus time. The dashed line shows the average velocity. As you can see, the car's velocity is sometimes higher and sometimes lower than this average value. In order to determine it, we have to consider small and smaller time intervals and use calculus. We have a special case when the object moves with constant speed and on a straight line. In this situation, the instantaneous velocity will be equal to the average velocity at any time. If we solve the equation of average velocity for the final position, we obtain the equation of motion for this special case. In one dimension, it is more evident that this is the equation of a straight line. Acceleration is the change of velocity with respect to time. It is also a vector, like position and velocity. As with the velocity, we can derive an average acceleration as the increment in velocity divided by the time increment. In one dimension, it is expressed like this. However, we have to remember that, as a general rule, the instantaneous acceleration will be different from the average acceleration. We have another special case when an object's velocity is changing, but the rate of this change, the acceleration, is constant. These are the equations of motion in this case. In just one dimension, they are written like this.